Good afternoon, friends. We'll start the fourth chapter for 570, API 570. That is same in 2018 and 16, only this Errata. So I already seen Errata, so I'm not going to that. Owner user inspection organization. General. An owner user of a piping system shall exercise control of the piping system, inspection program, inspection frequency and maintenance, and is responsible for the function of an authorized inspection agency in accordance with provision of API 570. The owner-user inspection organization also shall control activities relating to the rating, repair, and alteration of piping system. Responsibilities: owner-user organization, systems and procedures. Inspection organization audits. Each owner-user organization should be audited periodically to determine if they are meeting the requirements of an authorized inspection agency as defined in the inspection code. The audit team should consist of people experienced and competent in application of this code. The audit team should typically be from another owner, user plant side or company central office, or from third-party organization experienced and competent in refining and or petrochemical process plant inspection programs, or a combination of third-party and other owner-user sites. Owner-user responsibilities are being properly discharged. MOC, management of change. The owner-user is also responsible for implementing an effective MOC process that will review and control changes to process and to the hardware. Address the issues concerning the adequacy of the pressure piping design and current condition for the proposed changes, anticipate changes in corrosion or other types of damage and their effects on the frequency on the pressure piping, update the inspection plan and the records to account for those changes. Integrity Operating Window, IOWs. The owner user should implement and maintain an effective program for creating, establishing and monitoring integrity operating in Windows. Particular attention to monitoring integrity operating Windows should also be provided during startups, shutdowns, and significant process upsets. Piping engineer. The piping engineer is responsible to the owner user for activities involving design, on engineering review, rating analysis or evaluation of piping system and PRDs covered by API 570 as specified in this code. Repair organization. All repair and alterations shall be performed by a repair organization. Authorized piping inspector. When inspection, repair or alterations are being conducted on piping system, the designated authorized piping inspector shall be responsible to the owner user for determining that the requirement of API 570 on inspection, examination, quality assurance, and testing are met. The authorized piping inspector may be assisted in performing visual inspections by the properly trained and qualified individuals who may or may not be certified piping inspectors, examiners, and operating personnel. Personnel performing NDE shall meet the qualification identified in here, but need not be authorized piping inspectors. However, all examinations results shall be evaluated and accepted by the authorized piping inspector. See the definition of an authorized piping inspector. The examiners shall perform NDE in accordance with job requirements. The examiner employer shall maintain certification record of the examiners employed, including dates and results of personal qualifications. These records shall be available to the inspector. Other personnel operating, maintenance, engineering process, and mechanical or other personnel who have been special knowledge or expertise related to particular piping systems shall be responsible for timely notification to the inspector and or engineer of his issue that may affect piping integrity, such as the following. Any unusual conditions that may develop: noises, leaks, vibration, movement, insulation damage, external piping deterioration, support structure deterioration, significant bolting, corrosion, etc. Development of an inspection plan. The inspection plan shall be developed by the inspector and or engineer. A corrosion specialist shall be consulted to identify, clarify potential damage mechanism and specific location where degradation may occur, especially where localized corrosion or cracking mechanism may involve. A corrosion specialist shall be consulted when developing the inspection plans for piping system that operates at elevated temperatures above 750 degrees centigrade, 400 750 degrees Fahrenheit, 400 degrees centigrade, and piping systems that operate below the ductile to brittle transition temperature. Minimum contents of an inspection plan. The inspection plan shall contain the inspection tasks and schedule required to monitor, identify damage mechanisms, and assure the pressure integrity of the piping system. The plan should define the types of inspection needed: internal, external, on-stream, non-intrusive. Identify the next inspection date or each inspection type. Describe the inspection methods and ND techniques. Describe the extent and location of inspection and ND HTMLs. Describe the surface cleaning requirements needed for inspection and examination for each type of inspection. Describe the requirements of any needed pressure test, types of test pressure, test temperature, and duration. Describe any required repairs, if known or previously planned before the upcoming inspection. Describe the types of damage anticipated or experienced in the piping system. Define the location of the expected damage. Define any special assets and preparation needed. Generic inspection plans based on industry standard and practice may be used as a starting point in developing specific inspection plans. Inspection plans may or may not exist in a single document. However, the content of the plan should be readily accessible from inspection data system. The type of inspection needed: internal, external, on-stream, non-intrusive. Identify the next inspection date. Describe the inspection methods, ND techniques. Each ND techniques they have to follow. Describe the surface cleaning requirements needed for inspection. Describe the requirements of any needed pressure test. test temperature and duration, describe any required repairs if known or previously planned for upcoming inspection, describe the types of damage, anticipated location, expected damage, define any special assets and preparation needed. RBI. General, an RBI analysis may be used to determine inspection intervals or due dates and the type and extent of future inspection examination. The RBI analysis, when conducted in accordance with API 580, shall include all of the inspection planning elements noted in API 580, Section 5.2. When the owner user choose to conduct an RBI assessment, it shall include a symbolic systematic evaluation of both the probability and the associated consequences of failure in accordance with requirement of API 580, API 581 provides a set of methodologies for assessing risk, both PDF and COF, and for developing inspection plans that are consistent with the key elements defined in API 580. Identifying and evaluating potential damage mechanism, current equipment condition, and the effectiveness of the past inspections are important steps in assessing the probability of piping failure. So where piping failure before, there may be a chance nearby things, there must be a piping failure. Identifying and evaluating the process fluids, potential injuries, environmental damage, equipment downtime are important steps in assessing the consequences of piping failure. Identifying integrity operating windows or key process variables is an important adjunct to RBI. Probability of assessment. The probability of assessment shall be in accordance with the requirement in API 580 and shall be based on all forms of damage. This could reasonably be expected to affect equipment in any particular service. Additionally, the effectiveness of the inspection practices, tools, and techniques used for finding the potential damage mechanisms shall be evaluated. Other factors that should be considered in probability of assessment include appropriateness of the materials of construction for the damage mechanism, equipment design condition relative to operating conditions, appropriateness of the design codes and standard utilized, effectiveness of corrosion monitoring programs, the quality of maintenance and inspection quality assurance quality control programs, both the pressure retaining and structural requirements, operating condition both past and projected and review of potential fouling as its impact damage mechanisms prior to mechanical corrosion or failure, history of the piping system circuit, review of inspection history. Consequence assessment. The consequence of a release is depend on the type and amount of process fluid contained in the equipment. The consequence assessment shall be in accordance with the requirement of API 580 and shall consider the potential incidents that may occur as a result of fluid release. The size of potential release and the type of potential release includes explosion, fire, toxic exposure. The assessment should also determine the potential outcomes that may occur as a result of fluid release or equipment damage, which may include health effects, environmental impact, additional equipment damage, and process downtime or slowdown. Documentation. It is essential that all RBI assessments be thoroughly documented in accordance with the requirements of API 580, clearly defining all the factors contributing to both probability and consequences of the failure of the equipment. After RBI assessment is conducted, the result can be used to establish the equipment inspection plan and better define the following: the most appropriate inspection and NDE methods, tools, techniques, the extent of NDE, percentage of equipment to examine, the internal interval or due date of internal where applicable, external and on-stream inspection, the need of pressure testing after damage has occurred or after repairs alteration have been completed, the prevention and mitigation steps to reduce probability of consequence of equipment failure, repairs, process changes, inhibitors, etc. Frequency of RBI assessments. When RBI assessments are used to set equipment inspection intervals or due dates, the assessments shall be updated after each equipment inspection as defined in API 580 section. The RBI assessment shall updated at least every 10 years or more often if process of hardware changes are made or after an event occurs that could be significantly affect the damage rates of damage mechanism. The RBI assessment shall be reviewed and approved by the appropriate qualified personnel per API 580 inspector. Preparation for inspection. Record review. Before performing any required inspection, inspectors shall familiarize themselves with the prior history of the piping system for which they are responsible. Inspection of types of location of damage, modes of deterioration and failure. Piping system damage types. Describe common damage mechanisms and inspection techniques. 571. API 571 describe common damage mechanism and inspection techniques to identify them. Some example mechanism applicable to process piping system are as follows: general and localized metal loss, sulfidation, and high temperature H2S H2 corrosion, oxidation, microbiological induced corrosion, naphthenic acid corrosion, erosion, corrosion, galvanic corrosion, atmospheric corrosion, corrosion under insulation, cooling water corrosion, boiler water condensation corrosion, soil corrosion, ammonium bisulfide and chloride corrosion, carbon dioxide corrosion, surface connected cracking, mechanical fatigue cracking, thermal fatigue cracking, caustic stress corrosion cracking, polyionic stress corrosion cracking, sulfide stress cracking, chloride stress corrosion cracking, subsurface cracking, hydrogen induced cracking, wet hydrogen sulfide cracking, high temperature microfissuring, microvoid formation and eventual microcracking, high temperature hydrogen attack, creep stretch rupture, metallurgical changes, graphitization, temper embrittlement, hydrogen embrittlement, blistering, hydrogen blistering, general types of inspection and surveillance. General. Different types of inspection and surveillance are appropriate depending on the circumstances of the piping system. This includes the following types of inspection and inspection focus areas: internal visual inspection, on-stream inspection, thickness measurement inspection, various NDE examination, external visual examination, vibrating piping inspection, supplemental inspection. Inspections shall be conducted in accordance with the inspection plan for each piping circuit or system, referred to Section 6, for the interval, frequency, and extent of inspection. Corrosion and other damage identified during the inspections and examinations shall be characterized, sized, and evaluated per Section 7. Revision to the inspection plans shall be approved by the inspector and or piping engineer. Internal visual inspection. Internal visual inspection are not normally performed on piping. When practical, internal visual inspection may be scheduled for systems such as large diameter transfer lines, ducts, catalyst lines, or other large diameter piping system. Such inspections are similar to nature to pressure vessel. Pressure vessel inspections and should be conducted with methods and procedures similar to those outlined in 510, API 510, API 522. Remote visual inspection technique can be helpful when inspecting piping which is too small to enter. On-stream inspection. The on-stream inspection may be required by the inspection plan. All the on-stream inspection, sorry, on-stream, all the on-stream inspection should be conducted by either an inspector or examiner. An on-stream inspection work performed by an examiner shall be authorized and approved by the inspector. The external thickness measurement inspection described in 5.6.2 may be a part of an on-stream inspection. Thickness measurement inspection and various NDE examinations. Thickness measurement are obtained to verify the thickness of piping components. The data is used to calculate the corrosion rates and remaining life of the piping system. Thickness measurements shall be obtained by the inspector or the examiner at the direction of the inspector. The owner user shall ensure that all individuals conducting thickness measurement are trained and qualified in accordance with the appropriate procedure used during the examination. Normally, the thickness measurements are taken while the piping is on stream. On stream thickness monitoring is a good tool for monitoring corrosion and assessing potential damage due to process of operational changes. The inspectors should consult with a corrosion specialist when the short-term corrosion rate changes significantly from the previous identified rate of determine the cause. Appropriate responses to accelerate corrosion rates may include obtaining additional UT thickness readings using profile RT in lieu of or to supplement UT readings, performing UT scans in suspect areas, performing other corrosion process monitoring, reviewing changes in operation process, making revision to the piping inspection plan, and addressing non-conformances. Okay, we'll stop here. So we'll continue from the next one.